Welcome to this lecture, and in this lecture we are going to start our object-oriented programming concept section in Java. Before starting the Java object-oriented programming, we just need to know why we choose the object-oriented programming. Suppose that you want to assemble your PC. You go to the hardware store and pick up a motherboard, a processor, some RAM and hard drive, and a cache power supply and put them together. You turn on your PC and the PC works. You need no worry whether the CPU is a 1 core or 6 core. Motherboards have 4 layers or 6 layers, and the hard drive have 4 plates or 6 plates. And you don't worry about the RAM is made in Japan or made in Korea, and so on. You just simply put the hardware components together and expect the machine is to run. Of course, you have to make sure that you have the correct interface. Example, you need to pick a IDE hard drive rather than SSD hard drive. If your motherboard support only IDE, you have to select the RAM with the correct speed rating, and so on. It is not difficult to set up a machine from a hardware component. Similarly, a car is assembled from a parts and a component such as they have the doors, they have the engines, wheel, brake and transmission. The components are reusable. Example, a wheel can be used in many cars of the same specification. Hardware such as the computers and the cars are assembled from the parts which are reusable hardware components. How about the software? You can assemble a software application by picking a routine here, a routine there, and expect the program to run. The answer is obviously no. Unlike hardware, it is very difficult to assemble an application from the software components. Since the advent of the computer 70 years ago, we have written tons and tons of programs and routines. However, for each new application, we have to reinvent the wheels and write the program from scratch. Why reinvent the wheels? Why rewrite the codes? You can write the better code, then use the code written by expert. So here we use the object-oriented programming concept because they have the reusability concepts. We can use code rather than 1 time, 2 times, 3 times, and 4 times. What is the traditional procedure of object-oriented programming languages? Traditional procedure of object-oriented programming language such as C, Fortran, COBOL, and the Pascal suffers some notable drawback in creating the reusable software components. The procedural object-oriented programmings are made up of functions. Functions are less reusable. It is very difficult to copy a function from one program and reuse in another program, because the function is likely to reference the global variable and other functions in the global world. Functions are not well encapsulated as a self-contained reusable unit. The procedural languages are not suitable of high-level abstraction for solving the real-life problem. For example, the C program uses constructs such as if-else, for loops, array, methods, and the pointers, which are low level and hard to abstract the real program problems such as a customer relationship means CRM system or a computer scorer game. The traditional procedural language separate the data structure, variables, and algorithms functions. Now we just see the object-oriented programming languages. The object-oriented programming languages are designed to overcome these problems. The basic unit of object-oriented programming is a class, which encapsulates both the static properties and dynamic operations within a box, and specify the public interface for using these boxes. Since classes are well encapsulated, it is easier to reuse these classes in the other words. OOPS combines the data structure and algorithm of a software entity inside the same box. OOP language permit high level of abstractions for solving the real life problems. The traditional or procedural languages such as C or Pascal force you to think in the term of a structure of the computer. Example, memory in bytes and the array, decision and the loops, rather than thinking in the term of the problems you are trying to solve. The OOP language such as Java, C++, and C Sharp let you think in the problem space and use software object to represent and abstract the entities of the problem space to solve the problem. As an example, suppose you wish to write a computer scorer game, which I consider as a complex application. It is quite difficult to model the game in the procedural object languages. But using OOP language, you can easily model the program accordingly to the real things appeared in the scorer game. Player attributes including the name, numbers, location in the field, and etc. Operations including run, jump, kick the ball, and etc. And we have the ball reference field, audience, and the weather. Most importantly, some of these classes, such as a ball and audience, can be reused in another application. For example, computer basketball game with little or no modification. So now what are the benefits of the object-oriented programming languages? The procedural object-oriented programming languages focus on procedures. With functions as a basic unit, you need to first configure all or out all the functions and then think about how to represent the data. The object-oriented languages focus on the components that the user perceives with objects as the basic unit. You figure out all the objects by putting all the data and operations that describe the user interaction with the data. The object-oriented technology has many benefits. Is in the software design, and you should think in the problem space rather than the machine bytes and the bits. You are dealing with high level concept and abstractions. Is in the design leads to more productive software development. Is in the software maintenance. Object-oriented software are easier to understand, therefore easier to test, debug, and maintain. Reusable software, you don't need to keep reinventing the wheels and rewrite the same function for different situations. The first and the safest way of developing a new application is to reuse existing code, full tested and prone codes. If we are talking about the object in our oriented programming language, so let's see what is the object here. So the object here is a car, pen, table, keyboard, bike, etc. So the proper example of the object is any entity that has a state and the behavior is known as an object. It can be physical or logical. Now we just see the example of an object. How to initialize an object. Here I just write a public class object. So it's better to create one other class with the name of class, and dog is an object here. So dog.java. So there is a class which is dog, and now I just declare the class here and then instance variable. I just creating the instance variable, so a string, so dog name, then a string breed, then integer, so we just always take the age in the integer, and then string, what is the dog color. Okay, now we just declare the constructor of the class. So public and dog, and then here I just write a string which is name, and then a string which is breed, integer, sorry, it's comma and integer which is age, and a string which is color. Okay, and then here I just write this dot game, sorry, this dot name which is equal to name, then this dot breed which is equal to breed, then this dot age which is equal to age, and at the last this dot color which is equal to color. Okay, so these are the constructor declaration of the class. Now we just see the methods. So method number one, public string. Here I just create a method which is the get dog name. So I just write get name here, and then what is the return? So it will return us which is name. Okay, then method number two. So method number two here is public string and get breed. Okay, so here I just write return and which is breed, so it's get breed here. Okay, now after that I just go to the method number three. So public, so here is a public string and it will get the age here. Okay, so this is the method number three and the method number four, so it will return age. Okay, then afterwards I just write public string, and here I just write, so this is not the string here because it's age, so it is integer, public int and then age, so string, and string is a color here. So this is method number 4 and it will return color. Okay, now so this is the method name which is get color. Okay, and here the method. So afterwards I just go to the override function, so string and to string. Okay, and then I just write a return, and return here is hi, my name is, and plus here, and here I just write this dot get name, and then here I just write plus, and then sorry it's plus, and then I just write slash n for the single line break, and my breed and age and color are. Okay, and I just write plus this dot get breed and plus comma here, and then plus this dot get age plus comma here, and then plus this dot get color. Okay, and then close this code here. Now after that this I just write public static void main, and then string and arguments. Then here I just write dog, and dog is Tuffy here, which is equal to new and dog. Okay, and then here I just write Tuffy, and then the dog name is Tuffy here, and then the breed is Papillon, and it's a Papillon, and then it have the age of 5, and the color here is white. Okay, and I just close this code, and I just print my this function to print screen dot print line, and then Tuffy dot to string. Okay, and I just close this code here. Now I just execute this code. So okay, and we have the error here, which is line number 28, and which is get breed. So here it's a B is a capital here. So now I just check. So you can see, hi, my name is Tuffy, my breed, age and color are Papillon 5 and white. So as I declare the variable like type name here, so this notify the compiler that we will use the name to the refer to data those type in type with a parameter variable. This declaration also reverse the proper amount of memory of a variable. So for reference variable, type must be strictly a concrete class name. In the journal, we cannot create an object of a abstract class or a reference interface. The object dog Tuffy, if we declare the reference variable Tuffy, like in our this example, its value will be undetermined, means it's null value, until an object is actually created and assigned to it. Simply, declaration or reference variable does not create an object. So this is a example of initialization of an object in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be learn about the concept of the classes in object-oriented programming. In last lecture, we just studied the object. So, what is an object? An instance is an executable copy of a class. Another name of instance is object. There can be any number of objects to a given class in memory at any one time. So what is an class? A class is a structure that defines the data and the method to work on that data. When you write the programs in the Java language, all program data is wrapped in a class, whether it is a class you write or class you use from the Java Platform API libraries. So, class is a blueprint or a template from which objects are created. Class is a group of similar objects, and the class is a logical entity. Class is declared using the class keyword. Example, here you can see public, class, and Java classes. So this is a class name here. Class does not allocate memory when it is created. There is only one way to define class in Java is using a class keyword. What you see here, which is public, class, and Java classes. So this is a keyword here, and this is a class name here. So let's suppose we use a bicycle class as an example. So the bicycle class. So with racing bikes, mountain bikes, and tandem bikes are a subclass of this bicycle class. Now we see the example of these Java classes. So here this is a modifier, keyword class, and the Java class's name. So now we just write private string and name. So I just close this code with a semicolon. So here we have the modifier, which is a private, and this is a type, which is a string, and then it's a name. Then now we just go to the void. So here I just write public void and set name, and this is a string, and a string is a value of n. So here we have the modifier, then the return type, which is void, and then the method name, which is set name, and then the optional parameters, which are string n, and then the exception list. Now here I just pass a name which is equal to n. So I just set the passed parameter as a name which is equal to n. Now here I just write public and then a string, and here I just write get, and the get is name here. So this is the modifier here, this is a return type, and then the name here. So now here I just return the set name. So here I just write return, and then return here is name. So I just return the set name here. Now I just go to the main method. So here after that I just write public static void and main, and then here I just write string arguments. Now here I just write Java class, and I just write here Java classes, and here Java classes 1, which is equal to new Java classes. Okay, so here we have the syntax of Java object creation. So here first of all I just write the class name here, then I just write the object name, which is Java classes 1, and then which is equal to new and the class constructor. Now I just set the name of the member of this object. So here Java classes 1 dot set name, and which is here I just write visitor. Okay, and then I just print the name. So here I just write system dot out dot print, and the print here is hello, and then the constructor, which is Java classes 1 dot get name function here. So now we just see the output for this code. So I just remove this bracket, and this is a print line, and now we just see the output. So here we have the output, which is hello visitor. So this is a concept of classes in object oriented programming. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture we are going to discuss about Java constructor. As you all know that all objects that are created must be given initial values, which can be done in two ways. The first way of doing this is to use the dot operator to access the instance variable and then assigning value to them individually. This can be a traditional approach to initialize all the variable of the object in the manner. The second approach takes the help of the methods like getData or initialize abstraction. To initialize each object individually, use a statement like here. I just write val1 dot get data and then 12 and 15. So parameters are here. Here in this lecture, you will be dealing with constructor of the Java and learn about how they are used within a Java program as how they are useful object-oriented programming concept. So here, what are the constructors? Constructor are special members functions whose task is to initialize the object of its class. It is treated as a special member function because its name is the same as the class name. Java constructors are invoked when their objects are created. It is named such object its constructor. The value example provide the data for the object. Example, they are used to initialize an objects. Every class has a constructor. When we don't explicitly declare a constructor for any Java class, the compiler creates a default constructor for the class, which does not have any return type. The constructor in Java cannot be abstract, static, final, or synchronized, and these modifiers are not allowed for the constructor. What are the key points means the rules for writing the constructors. Constructor of a class must has the same name as a class name in which it resides. A constructor in Java cannot be abstract, final, static, and synchronized. Access modifier can be used in constructor declaration to control its access. Example, which other class can call the constructor. Now we just see the characteristics of the Java constructor. An interface cannot have the constructor. Constructor cannot be private. A constructor cannot be abstract. I just told you that cannot be abstract, static, final, native, strict, or synchronized. A constructor can be overloaded. Remember that. Constructor cannot return a value. Constructor do not have a return type, not even void. And construct an abstract class can have the constructor. And the constructor name must be similar to that of the class name inside which it resides. And at the last, constructor are automatically called when an object is created. Instance variables and the methods of the class as known as a member of the class. Remember that. Constructor are not members for the reason constructor cannot be inherited but can be accessed by a subclass. Actually, Java constructor do not get inherited. Only their members like the variables or the methods get inherited. So, declaring a constructor as a final is useless and has no meaning as a constructor cannot be or hidden. Again, Java constructors should not be synchronized as it locks the object when created and hence as long as the object is not created any other object can be initiated. Now we have the two types of constructor. First one is the default constructor which have the no argument constructors and the second one is parameterized constructor. Now we just see what is a default constructor. So the default constructor which have the no arguments. is declare like here I just remove this one, and then here I just write public, and the public here is constructor. Okay, and then here I just write system dot out dot print line, and here I just write print line, and then I say this is a default constructor. Okay, so here is a quotation, so this is a default constructor. So this is the syntax of this no argument constructor. Now I just remove this, and here I just write another example of no arguments constructor. So I just import java.input output, and then we have the class name, which is the constructor here, and then I just write int, and int is num here. Then I just write a string and the name. So now here I just write constructor, and it's a constructor. So this would be invoke while object of the class is created. Now I just write system dot out dot print line, and the print line here is constructor called. Okay, and then we just go to the another class, which is the any class name. I just write gfg, and then I just write public static void main, and then it's an string, and so public static void main, and then string and arguments. Okay, so here I just write constructor, and I just copy this one and paste it here. So constructor is cons, which is equal to new constructor. Okay, so that this would invoke the default constructor here. Now I just write system dot out dot print line, and the print line here is cons dot name, and then system dot out dot print line, which is cons dot name. Okay, so this is a value of the default constructor, which is provided by the default value of the object, like 0 or null. Now now we just go to the another example of this constructor. So here I just remove this, and now we have the library, which is java.input output, and then we have the public class instructor. Now here I just write public, and then I just write constructor. Okay, so this is the constructor, and then here I just write system dot out dot print line, and the print line here is I am inside of default constructor. Okay, and now I write public static void, and void the main here, and then I just write a string and the arguments. Okay, and now I just create an object, so constructor, which is cons is equal to new constructor. Okay, so this is our default constructor, and the value of the default constructor is here when it's run this code. So you can see I am inside of the default constructor. Now we just see Java parameterized constructor. A constructor that has parameters is known as parameterized constructor. If we want to initialize the field of the class with your own values, then use parameterized constructors. Here is an example of parameterized constructor. So we have the class name which is parameterized and I just write cons. Now here I just write parameter and then I just make a default constructor here. Now system dot out dot println and the println here I just write default constructor. Okay, now here I just copy this name and then paste it here. So this is our class name as a default constructor. So now here I just parameterize constructor with two integer arguments. So here I just write parameterize and then I just write here int I as a parameter and int j as a parameter. Now here I just write system.out.println and here I just write constructor with two parameters. Okay, and then here I just create the parameterized constructor which is a class and then I just write three integer as arguments. So int I, int j and at last int k. So it is a integer k. Now here I just write system.out.println and the println here is constructor with three parameters. Okay, now here I just write the parameterized constructor with two arguments. One is an integer and one is a string. So parameterized cons which is integer I and string name. So here's the bracket and then I just open the program body. So system.out.println and the println here is constructor with int and string parameters. Okay, so here quotations. Now I just write public and static void main and then string and arguments. Now I just invoke the default constructor. So parameter obj which is equal to new parameter construct. Okay, so object and I just create an object to the default constructor. Now I just write parameterize object number 2 which is equal to new parameterized constructor. So this will invoke the constructor with two int parameters like this one. So I just called an object here for integer I and integer j. Parameterized constructor object 3 which is equal to new parameterized constructor. So I just create an object for this one. So this is the object for three integer parameters. And at the last, which is important one, object number 4, which is equal to new, and then the parameterized constructor. So I just pass the value here, which is 1, and then here I just write Java. Okay, so I just run this code so you can see. First one is a default constructor, then the default constructor, then the default constructor, and at the last we have the constructor with integer and the string parameters. Why we take three default and constructor here? Because we just not add our parameters in the object, like we cannot pass our parameters in the object. So the default constructor is because this is an empty parameters. So now here I just write 12 and 12. This is the value to our object number 2. So I just save this and run. So you can see constructor with two parameters. You can see here. Then I just write 13, 15, 14. Okay. So you can see it will tell us the constructor with three parameters. And this is our default constructor because we didn't pass any of the value in this constructor. So here we see another example of pre-parameterized constructor. So this is example of a weird compilation error. While we discussing a default constructor, we have seen that when we do not create a default constructor, Java compiler insert the default constructor into the code on our behalf. However, this is not always true. Now we see this example, and I just create a new class here, and the class name is parameterize constructor number 2 and .java. Here I just copy this class name and use as a default constructor. So parameterize, pass the parameters 1 int j. So int I and j here, and then I just write system.out.println and then parameterize constructor, and I just forget to close this code. Yes, and then I write parameterize constructor and passing the parameters, three parameters, I, int j, int k, and then here I write system.out.println, and the print line here is parameterized constructor, and here I write public static void main. Okay, and then string arguments, and here I just write parameterize constructor 2, which is the object is equal to new parameterized constructor. Okay, so it will be give us the compiler runtime error. So you can see exception in thread main java.lang error unresolved compilation program. Sorry, the problem. The constructor parameters is undefined. So the program throw the except compilation error because the statement example like statement parameterize constructor 2 and the object which is equal to new parameterized cons 2 is trying to invoke the no argument constructor, which we don't have in our program. You don't get the error if you remove the parameterized constructor from this code. This is because if you do not have any constructor in your class, Java compiler insert default constructor into your code on your behalf. However, if you implement any constructor, then you no longer receive a default constructor. Like here you can see I just add the construct parameter 2 because this is 1, and then here I just passed 12, 18 and 19. So I will receive no longer error. You can see construct parameterized constructor 2, and if we have these two parameters, so we have parameter construct. So these are the constructors and the types of constructor in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we will see the constructor overloading with the help of example in Java. Before we proceed further, let's understand what is the constructor overloading and why we do it. Constructor overloading is a concept of having more than one constructor with different parameter list. So, overloaded constructors are differentiated on the basis of their types of parameters or numbers of parameters. Constructor overloading is not much different than method overloading. In case of method overloading, you have multiple methods with same name but different in signature. Whereas in constructor overloading, you have multiple constructor with the different signatures. But only difference is that constructor does not have the return type in Java. So why we do constructor overloading? Constructor overloading is done to construct the object in different ways. Now we see the example of this constructor overloading in Java. So here I just define the class which is a public class and the constructor overloading. Here I just write integer which is the ID. So I am just taking the example of a student. So the student ID and then the name and then the student age. Then I just write after this I just copy this name and then the constructor overloading, and here I just write the integer. I just take one value with the integer and another one with a string, and the values are I and n. Now here I just write id which is equal to I, and then I just write name which is equal to n. Now constructor overloading, and then here I just write integer I, string n, and integer a. So integer I for ID, integer n for name, and integer a for age here. So here I just write ID which is equal to I, then the name which is equal to n, and then here I just write age which is equal to a. Now, I just copy this and paste it here, and here I just write void display, and the display here is system.out dot print line, and the print line is id which is a concatenation of name, and it's an empty string here, and then I just write plus name and plus, and then the string here, and at last age. So after that I just write public static void main, and then the string and the arguments, and then I just copy this class name and make the object for it. So constructor overloading, and object number one, which is equal to new, and the constructor overloading, and here I just pass the parameters. So the ID of the student is 11 and the name is Fayaz. And then the constructor overloading and the object number 2, which is equal to new constructor overloading, and I just pass the value which is 12 as a integer ID, then Khan as a string, and then the age is 25. Now object number 1 dot display, so I just display this func object, and object number 2 dot display. Okay, so this is the name of the object. So here I just run this program. So you can see at the first you can see Fayaz ID, and then the ID is 11, and then the name is Fayaz, and the 0 is the age. I didn't take the any parameter for it. And then 12 Khan and the 25. Now we see the another example of this constructor overloading. So here I just create a new class which is constructor overloading number 2 dot java. Okay, so this is a class name. I just copy this class name, and here I just write private and int roll number. Okay, now I just write overloading constructor overloading. So this is a class name here, and then I just write roll number, which is equal to 100. Then I just write constructor overloading 2, which is integer roll number, and then I just use this keyword and this. So this is used for calling the default constructor from the parameterized constructor. It should always be the first statement inside the constructor body. So now roll number, which is equal to roll number plus roll number. Okay, and then I just write public integer get roll number, and then return roll number. Okay, and then here is write public void set roll number, and which is the integer roll number. So here I write this dot roll number, which is equal to roll number. Okay, and then public static void main and the string arguments, and here I just write constructor overloading and create an object for it, which is equal to new constructor overloading 2, and then I just pass the value which is 12, and it's a value which is 12, and then the system dot out dot print line, and which is object dot get roll number. Okay, so I just check the output for this code. So this is the output for this code, which is the value of 112, and as you see in this example that we call the parameterized constructor during the object is creation. Since we have this keyword placed in the parameterized constructor, the default constructor got invoked from it and initialized the variable roll number. So this is an example of understanding the role of this constructor in constructor overloading. So this is also the example of chaining the constructor in Java. So chaining the constructor is a phenomena of calling one constructor from another constructor of the same class, since the constructor can only be called from another constructor in Java. Constructor chaining is used for this purpose. So here is a question which is, does constructors return any value? So you can say yes, constructors return the current instance of a class, but yet constructor's signature cannot have any return type. So this is the constructor overloading example in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be learn about the inheritance in Java. So inheritance in Java is a mechanism in which one object acquires all the properties and the behaviors of the parent objects. The idea behind inheritance in Java is that you can create a new classes that are built upon existing classes. When you inherit from an existing class, you can reuse the method and fields of parent class, and you can add new method to the field also. On the other words, the inheritance is the process by which one class acquires the properties, means the data members, and the functionalities, means the methods, of another class. Is called inheritance. I told you that the aim of the inheritance is provide the reusability of the code. So that a class has to write only the unique features, and rest of the common properties and the functionalities can be extended from the another class. So in inheritance we have the child and the parent class concept. The class that extend the features of another class is known as child class or a subclass, or we can also call it the derived class. The class those properties and the functionalities are used or inherited by another class is known as a private class, superclass, or a base class. So the question here is why we use inheritance. For inheritance, we used for method overriding, means runtime polymorphism can be achieved. So in method overriding, uh, the runtime polymorphism can be achieved. So the polymorphism, we just learned about the polymorphism in our next upcoming lectures, and the another benefits why we use the inheritance in Java is for code reusability. So how to create an inheritance in our Java? So here I just go to the default package and new. Here I just click on the package source and the package. So here in the package I just write inheritance, okay, and then finish. So you can see we have a new package here. So now here I just write the class name, and the class name here is a dot java. So what is the syntax of the inheritance? So inheritance syntax is class, subclass, name, and extends. So extend is a keyword which is used for inherit, and the super class name means the parent class name here, and the methods and the field. The extends keyword indicates that you are making a new class that's derived from an existing class. The meaning of the extend is to increase the functionality. In the terminology of Java, a class which is inherit is called parent, or a superclass, and the new class is called the child class or a subclass. Here I just create a package which is the name of inherit, and then I just create a class which is A. So A is a parent class here, and I just add a new child class which is b.java. We have the two classes here which is A and the B. So in the A class, I just remove this one and I just write a float and salary. So the salary of employee here is 40,000. Okay, and it is a float value. So this is a parent class. Now here I just go to the child class. So this A class will be, so this B class will be inherit from A class, and it will get the value of the float salary. Now I just go to the B class, and here I just write class, and then here I just write B, and I just choose the extend keywords. So class B extend from class A, and here, and I just remove this one like this one, and here I just write class B, and it is extend from class number A. So I just make A class which is parent and the B class which is child. Here I just write int and bonus which is equal to 10,000. So give it the bonus to the 10,000 which is salary. Okay, here I just write public, and it's public static void main, and then strings and the arguments. Now here I just write class B, and here I just write salary for S and new B. Okay, and then I just write system, so B is a capital here. So system dot out dot print line, and the print line here is, and the print line here is salary after salary with, so only salary I just write here, and then I just write plus S dot salary. Okay, so I just concatenate the salary here, and then system dot out dot print line which is salary after bonus. Okay, and then here I just write plus S dot bonus. Okay, so this is the bonus here. So now I just check the output for this code, so you can see I just click on the execute, and then you can see salary is 40,000 and it is a float value here, and salary after bonus is 10,000 which is the bonus here. Now we see what is the logic behind it. Here we have two classes. One is the class A and one is the class B. So the A here is a parent class, and the B here is the child class. Okay, now we have the one float value which is a salary in the A class. So B inherit the value from which is the salary from A class, and then add with the bonus which is a integer and the value of the bonus is 10,000, and the salary is the 40,000 here. So B inherit from A. So A is a parent class here and the B is the child class here. Now we see the another example of inheritance. I just take the package name, which is inheritance 2, and then here I just create a two classes name. So one is the teacher dot java here, and the another class name which is teacher is computer teacher here. Okay, so and yes, so in the teacher class I just write a string and designation. Okay, so designation is teacher, and then I just take one another string which is college name, and the college name here is spread tax. Then I just take void and does. Okay, and then system.out.println, which is teaching. Now I just create a parent class with the name of a string which is designation and the string which is the college name. Now I just go to the child class here. So here I just write public class and the class name, and here I just write extends, and extend is the teacher. Okay, so now I just write a string, and here I just define the subjects. So the main subject which is equal to computer science. Okay, and then I just write public static void main, and then strings, string and the arguments, and then here I just write computer teacher. So I just copy this name and paste it here, and I just create the object to it which is equal to new computer teacher, and then I just call the object dot println, and then obj dot college name, and then system dot out dot println, which is object dot designation, and then system dot out dot println, which is object dot main subject, and here is a object dot college name. Okay, and here I just call this method which is does. Okay, void does. So I just create an object to it, so object dot does. So I just check this code, so you can see we have the college name which is spread text, then the designation is the teacher here, and the subject is the computer science, and the object does what I just called, which is the name of teaching. You can see here is a teaching. So in this example we have the base class or a parent class which is teacher, and a subclass which is the computer teacher. Since a computer teacher extend uh, computer teacher extend the designation and the college properties and the work method from the parent class. We need not to declare these properties and the methods in the subclass. You can see we just not need to declare these properties in the subclass. Here we have the college name, designation, and the work method which are common to all the teachers as we have declared them in the base class. This this why the child classes like computer teacher or a music teacher or a Java teacher or a Python teacher do not need to write the code and can be used directly from the base class. So the based on this example, we can say that the computer teacher, uh, ISA teacher, that's mean that a child class has a relationship with the parent class. This is inheritance is known as the relationship between the child and the parent class. Remember that the derived class inherits all the members and the methods that are declared as a public or a protected. If the members are or methods of the superclass are declared as a private, then derived class cannot use them directly. The private members can be accessed only in its own class. Such private member can only be accessed using the public or a protected gather and shatter the methods of the superclass as shown in this example. Now we see the types of inheritance in Java. On the basis of class, there can be three types of inheritance in Java. One is a single, another one is a multi-level, and the hierarchical. In Java programming language, the multiple and a hybrid inheritance is supported through the interface only. We will learn about the interface later in our this course. So note that the multiple inheritance is not supported in Java through the classes. So first of all, I just discuss the single inheritance in Java. Single inheritance refers to a child and the parent class relationship where a class extends the another class like B class extend A class. The multi-level inheritance refers to the child class and the parent class relationship where a class extends the child class. For example, class C extend class B and B extend class A. Like this will extend class B and the class B extend class A. So class A is a parent class to the class B and class B is a parent class to the class C. Now we see the hierarchical inheritance. Hierarchical inheritance refers to a child and the parent class relationship where more than one classes extend the same class. For example, class B and C is extend the same class A. Means this is a parent class to the class C and class B also. So the multiple level inheritance refers to the concept of one class extending more than one classes, which mean that a child class has two parents class. Means this child class has two parent class which is the class A and the class B. For example, class C extend both classes A and B, but Java does not support multi-level inheritance. Now we just see hybrid inheritance. Combination of more than one types of inheritance in a single program. For example, class A and B extend class C and another class D extend class A. So class A, then this is a hybrid inheritance example because it is a combination of a single and hierarchical inheritance. Means all these are the parent and the child classes to each other. So now we just see the example of single level inheritance. Single level inheritance is very easy to understand. When a class extends another class, only then we call it the single class, like this one. This class A extend, sorry, the class B extend class A. So this is a single level inheritance. Now we just see another example of the single level inheritance. So the package and single inheritance. Okay, and here I just create a class which is a class a dot java, and then I just write b dot java. Here we have the package name, which is a single inheritance, and then here I just write public void method a. Okay, so I just create a method here, and then system dot out dot print line, and the print line here is base class method. Okay, and now we just go to the b class. So here I just simply create the method which is a class a, and here I just write class b and use extends keyword, and it is extend the class a. Here I just write public void method b. Okay, and then I just write here system dot out dot print line, and the print line here is child class method, and then public static void main, and then string and the arguments. Now here I just create an object to it. So b class b and object which is equal to new b, and then so this is a static. So here I just write object dot method a. So I just create an object to the method a, and this is object to the method a, and it is calling here a super class, means it is calling our parent class here, and then the method 2 calling the local method, creating the object to the local method. So the method b here. Okay, so this is method b. Now we just check the output. So you can see our base class method and the child class method. You can see the base class method, it is inherit from the base class, and then the child class here. Now we see the example of the multiple inheritance. Sorry, the example of the multi-level inheritance. So here I just create a package which is, so not here, and in the source package and multi-level inheritance and its inheritance. Okay, here I just create a class which is the name of car dot java, and then here I just create the method. So public, and the public here is car, and then system dot out dot print line which is class of the car. Then I just define the void, so it will return nothing. So here is another class which is a vehicle, and the method here which is a vehicle, and then system dot out dot print line, and here I write vehicle type which is car. Okay, then here I just go to the another class, and here I just create a class which is bmw dot java. So here we have another class, and here I just write extends car. So class BMW extend our parent class, which is car, and the public BMW is a method here. And then system.out.println, which is class BMW. And here I just write public void and brand air is system.out. And system.out.println, and the brand is BMW. Okay, now here I just write public void and speed method. Now system.out.println, and the print line here is maximum 120 kilometer per hour. Okay, and after that I just go to the another class. So here I just write class, and class here is BMW 15. Okay, and then here I just write BMW 15 extends BMW. So the car is a parent class to the BMW, and BMW is a parent class to the BMW 15. Now here I just write public BMW 15 method, and then I just write system dot out dot print line, and the print line here is BMW and model is 2015. And then I just create one another method which is public and void speed of it, and the speed here is system.out.println, and then it's maximum up to 180 kilometer per hour. Okay, and then here I write public static void and the main method, and then string arguments, and then here I write BMW 15, and then create an object to it which is equal to new and BMW 15. Then I just call, and this is BMW 15. Okay, and now object dot vehicle type, and then object dot brand, and then object dot speed. Okay, so I just check the output. So you can see the class BMW, the model is 2015, vehicle type is car, brand is BMW, and maximum speed of it is 150 kilometer per hour. So in this example we have the three classes, which is car, BMW, and the BMW 15. We have done a setup class which is BMW extend the car, and the class BMW 15 extend the BMW. With the help of the multi-level inheritance setup, our BMW 15 class is able to use the method of both the classes like BMW and the car classes. So this is the example of the multi-level inheritance in Java. Now we see the hierarchical inheritance. So I just create one another package which is hierarchical, and hierarchical is inheritance. Okay, now I just create the class, and here I just create the class which is animal.java. So here I just write the class name which is animal and void animal is eating, and then this is a method here which is the eat method, and then system.out.println, and println is eating. Then we just go to the class. So here I just create the class which is cat.java, and here I just write extend animal. So cat extend the class which is animal, and void I just write milk. So not an eat here, so I just write drink. Okay, and here's the milk. Then here I just write system.out.println, and then I just write meow. Okay, and then we just go to the another class. So here is a class which is first I just inherit this class, so it's a meow here, and then I just write the class which is dog.java. So dog inherit from animal, and then I just write here void and bark, and then so it's an animal class. So okay, and then here I just write bark, and this is cat. Yes, okay, and here I just write bark, and then system.out.println which is barking. Now we just go to the hierarchical inheritance class. So now here I just create the class which is the name of hierarchical dot java, and then here I just write public static void main, and then string arguments, and this is string arguments, and then here I just write cat c which is equal to new cat, and then c dot milk. Okay, and then c dot drink. Okay, so you can also call it the dog functions too. So here I just check the output, so you can see I just call the two object which is milk, and the milk function is meow here, and then the animal which is drink, and the eating. So this is the hierarchical inheritance example in Java. So now we just see the multiple inheritance. Why Java not support the multiple inheritance? To reduce the complexity and simplicity the language, multiple inheritance is not supported in Java. Consider a scenario: A, B, and C are the three classes. The class C inherit class A and the class A inherit class B. If a A class and the B class have the same method and you call it from the child class object, there will be ambiguity to call the method of a A or a B class, since The compiler time error are better than the runtime error. Java renders compiler time error if you inherit two classes. So whether you have the same method or a different method, there will be compile time error in your multiple inheritance. So these are the types of inheritance and the inheritance in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about the abstraction in Java. Abstraction is the process of hiding the implementation's detail and showing only the functionality to the user. Another way, it shows only important things to the user and hide the internal details, for example, sending SMS. You just type the text and send the message. You don't know the internal processing about the message delivery. Abstractions let you focus on what the object does instead of how it does it. There are two ways to achieve the abstraction. One is the abstraction class, means you can write the abstract class, which is the abstraction level of 0 to 100%. And the another way you can achieve the abstraction, which is the interface. A class that is declared using the abstract keyword is known as abstract class. Remember that. It can have the abstract method as well as a concrete method. A normal class means a non-abstract class cannot have the abstract method. Remember that. So why we need abstract class? Let's say we have a class A, like this one. You can see the class A that has a method which is, or I just simply write it's a class animal, okay? And the method of it, this class is sound, and the subclass of this class is dog, lion, horse, cat, or any of the animal. Since the animals sound different from one animal to the another animal, there is no point to implementation this method in the parent class. This is because every child class must override the method to give its own implementation detail. Like lion class say roar, in this method dog class will say woof. So we can know that all the animal child classes will and should override this method. Then there is no point to implement this method in the parent class. Thus, making this method abstract would be the good choice, as by making the method abstract, we force all the subclasses to implement this method. Otherwise, you will get the compilation error. Also, we need not to give any implementation to this method in the parent class. Since the animal class has an abstract method, you must need to declare this class abstract. Now each animal must have a sound. By making this method abstract, we made it compulsory to the child class to give implementations detail to the method. This way we ensure that every animal has a sound. Now we see the example of the abstract class. So I just make this example, I just delete this, and here I just create one another class with the name of animal. Okay, so animal dot java here. Now here I just create the class name which is abstract. So here I just write abstract. So abstract is a keyword, and this is the class name which is abstract and animal. So I just remove the public and then make the parent class with the abstract class. Now I just declare the abstract method. So public abstract, and then abstract is void sound. Now here I just declare, not here, I just create one another class with the name of dog, because dog is a category of animal. So I just write java dog dot java. So here public class, and I just inherited and use extend and animal. Okay, so this is a super class which is animal and public void and sound. So here I just write system dot out dot print line, and the print line here is, and the print line is wolf. Okay, and then here I just write the main method, which is public static void main and string, and the arguments, so it's string and arguments. Okay, and then here I just write, I just create the object to it, so animal, and the object which is equal to new and dog, so dog here, and then create the object to sound. So now we just check the output, and you can see it is classes inherit from the animal class, and which is the object of sound, which is wolf. Hence, for such kind of example, we generally declare the class as an abstract and later is a concrete class. Extend these classes and override the method accordingly and can have their own method as well. So here now we just understand the real scenario of an abstract class. So now here I just create another example for the abstract class. So here I just write abstract shunt2, and then here, sorry, it's I just not create a class, I just want to create the package here. So the package is abstraction 2 dot, so 2. Okay, and here I just create a class which is a name of shape dot java. Okay, now here I just change this shape name with the abstract, and abstract class which is shape, and in the abstract class I just create one another class which is abstract void and draw. Okay, so not a, this is not a class, this is a method. So draw here, and then after that I just go to the real scenario of implementations in abstraction. So here I just create one another class which is the name of rectangle, and then here I just write the class name which is rectangle, and it is extend with shape. So this is our shape class which is super class. Then here I just write void and void which is draw. Okay, and then here I just write system dot out dot print line which is drawing rectangle. Okay, and close with the double quotation. Now here I just create one another class, and then here I just write circle. It's circle dot java. Now here public class which is circle and extends shape. So this is our shape is a parent class and circle is inherit from the shape class. So now here void and draw and then system dot out dot print line, and the print line here is drawing circle. Okay, now we just go to the real scenario of the programmer or the users. So these classes I just create for the user view. So here I just make a method there to the void, and then I just create one another class with the name of test abstraction dot java. So this is a programmer oriented classes, and here I just write public static void main. So this is the main method, and then a string arguments, and then here I just write shape which is s is equal to new and circle, and then I just create the scenario for the object providing through the method, like example get shape method here, and s dot draw. Now let's check the output. So you can see draw the circle because I just called an object which is the circle. So in this example, shape is an abstract class, and here shape is abstract class. You can see here a little small a. So shape is an abstract class here. Its implementations is provided by the rectangular and the circle class. Mostly we don't know about the implementation class. Example, hidden to the end user. An object of the implementation class is provided by the factory method. So the factory, what is a factory method? A factory method is a method that return the instance of the class. We will learn about the factory method in later in our tutorials or lectures. So this is the example of the real scenario of the abstract class. Like we just make three classes for the user oriented and then one for the abstract level for the programmer oriented or the users. So this is example of abstracts in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about the interface in Java. Interface is a pure abstract class. They are syntactically similar to the class, but you cannot create the instance of an interface, and their methods are declared without any body. Interface is used to achieve the complete abstraction in the Java. When you create an interface, it defines what a class can do without saying anything about how the class will do it. So now we just see why we use Java interface. There are mainly three reasons to use the interfaces in Java. It is used to achieve the abstraction. This is the one step. By interface, we can support the functionality to the multiple inheritance. This is the second point why we use the Java interface, and the third one is it can be used to achieve losing the coupling. So there are some rules of using the interfaces. First one is Methods inside interface must not be static, final, native. All variables declared inside the interface are implicitly public, static, final, and the variable which are constant. All methods declared inside Java interfaces are implicitly public and the abstract. Even if you don't use the abstract or abstract keyword, interface can extend one or more other interface. Interface cannot implement a class, and at the last, interface can be nested inside another interface. Now we see the example of the interface and see how we implement the interface. Here I just create a class which is printable. So in this example, interface printable has only one method. Its implementation is provided in the another class which are I just create one another class which is a.java. Okay, here in the printable class I just write void and print. Okay, this is the method, and now we just go to the another class which is a. Here I just write the public class a, and remember that here I just declare interface with the public, and I just replace class with interface, and then we just go to the public and the class a, and here I just use a keyword which is implements, and here I just write printable which is our super class. Now I just go to the public void print method, and then system.out. And here it's a capital P, so I just write system.out.println, and the print line here is a string and the arguments. Now sorry, here I just write hello and then close this code, and then I just create a main, and which is public static void main and string arguments. So this is a main method here, and then here I just write a and then object which is equal to new and a. So this is our class name, and then object dot print. So this is our print method, so I just call it the print method. Now I just check the output for this code, and the output is hello. You can see it will print this method here. Now we just go to the another example of this interface, and the example for the bank. So here I just create a new package which is interface, and interface is the one. Okay, now here I just create a class which is the name of bank. So this is a class name, and here I just write public and interface. So interface is a bank, and then it's float is a rate of interest. So this is a method here. Now I just create one another class with the name of the bank. So the bank is ANZ. So ANZ.java. Here I just write class and the class name, and then implementation, So implements, so it's implements and then the bank name, which is a superclass. Now here I write public and float and the rate of interest. Okay, and then I just write return, and return is 9.5 f. Okay, now we just go to the another class, which is the bank name nib.java, and then here I just write implements and the superclass name, which is bank, and the bank is a superclass name here, and then I just write public float rate of interest, and then here I just write return 9.7 f. Okay, and we just go to the another class, which is the main class here. So I just write the name of this class, which is test interface 2, and here I just define the main method, which is public static void main, and then strings and the arguments. So here bank b, which is equal to new, and anz, and then here I just write system.out.println, which is the rate of interest here is, and plus b dot rate of interest. Now I just check the output. So you can see the rate of interest on ANZ Bank is 9.15. So this is an example of the interface in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be learn about what are the difference between the abstract class and the interface. Abstract class and the interface both are used to achieve abstraction, where we can declare the abstract methods. Abstract class and interface both cannot be initiated. An abstract class can extend only one class or one abstract class at a time. An abstract class can extend another concrete, regular, or abstract class. And the third number, an abstract class can have both abstract and the concrete methods. So we let's just see the interface. So the interface can extend any numbers of interfaces at a time. An interface can only extend another interface. An interface can have only abstract method, and an interface can have only public abstract method. Here we just see a simple example of where we are using the interface and abstract class both together. So here I just make a package which is the name of abstract versus interface, and just create the two classes, which is abstract1 and interface.java. So here in the interface class, I just write the interface public class interface, and here I just remove this interface, and here I just write interface. So public class interface and the class name here is interface. Then I just write void and a. So void a for by default the public and abstract method. Here we just create the for math and means creating interface that have the for method. Like this is our interface, and I just create a first method here, and then here I just write abstract, void b, then void c, and at the last a method which is void d. Now we just go to the abstract class. So here I just give it the name which is abstract, and abstract is the class name of abstract one, and then here I just write implements, and here it's implements interface. Okay, and this is with the capital one because it's the class name which is interface, and this is abstract. Now here I just write public void, and I just call my C method, and then here I just write system dot out dot print, and then it's a print line here. So the print line here is I am C. Okay, so I just create an abstract class that's provide the implementation of one method from our this class name which is interface. So here I just close this code, and I just remove this, and then here I just write class, and it's a capital S of the system. Now we just go to the creating a subclass of the abstract class, and here I just go to create a new which is a class, and here I just give it the name to the class which is subclass dot java. Okay, so here we just need to provide the implementation of rest of the method here. So here with a class, and class name is subclass, and here I just extend our class which is the name of abstract one, and then here I just write public void, and I just write the method a which is system dot out dot print line, and the print line here is I am method a, and then I just copy this code, and here I just only declare the methods which are public void and method b, and just remove this, and here I just write public void and the method d because we just already implement our method which is the name of c. Now we just create one test class, or I just say this is an object class to create, not create, to call the object of a interface class. So here I just create new and class, and here I just write object1 dot java because I am just creating the object here. So the class name which is object1, and it's a main method here, and then a string, and the arguments here, and here I just write our class name which is interface. So I is a capital here, and the interface here, and then I just write a which is equal to new, and then our subclass name, and then here I just write a dot a method, and a dot b method, and a dot c method, and a dot d method. So I just call my methods here, and now I just check the output for this code. So you can see I just call the method number one with an interface. So here is a I am a, then I am a, I am c, and I am a. So this is a simple example of interface and abstract class in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about the polymorphism in Java programming language. The word polymorphism literally means a state of having many shapes or the capacity to take on different forms. When applied to the object-oriented programming language like Java, it describes a language's ability to process the objects of the various type of classes through a single uniform interface. Polymorphism in Java has two types. One is a compile time polymorphism, what we call it the static binding, and the runtime polymorphism is dynamic binding. Method overloading is an example of a static polymorphism, while method overriding is an example of dynamic polymorphism. Here I just gave you a little knowledge about ISA relationship. In OOP, ISA relationship is completely inheritance. That means that the child class is a type of the parent class. Like A has A relationship is dynamic runtime binding, while inheritance is a static compile time binding if you just want to reuse the code and you know that the two are not of the same kind. Use this composition like IS and A relationship. So now we just come to our on topic, which is the polymorphism. An important example of polymorphism is how a parent class refers to a child class object. In fact, any objects that satisfy more than one ISA relationship is polymorphic in nature. For instance, let's consider a class animal. Here I just write animal. We have the class which is the name of class animal. And we have the class means a subclass which is cat. So cat is the also animal and it is a subclass of animal. Okay. So any cat means IS animal. Here cat satisfy the ISA relationship for its own type as well as its superclass name is the animal here. The good reason for why polymorphism is needed in Java because the concept is extensively used in implementing inheritance. It plays an important role in allowing objects having different interval structures to share the same external interface. Polymorphism is started clear by itself and one which mapped for many. On the other hand, we have the another definition of the polymorphism, which is the polymorphism is a capability of a method to do different things based on the object that it is acting upon. In other words, polymorphism allows you to define one interface and have the multiple implementations. Now, here we just see the example of the static polymorphism. So in Java, static polymorphism is achieved through method overloading. Method overloading means there are several methods present in a class having the same name but different types like order numbers of parameters. At compile time, Java knows which method to invoke by checking the method signature. So that is called compile time polymorphism or a static binding. The, the concept will be clear from the this example. Now we just create here like the polymorphism and I just create the class which is static. polymorphism. Okay, dot Java. Here in this class I just write public integer add, and we have the parameter which is int x and int y. Now here I just write return x plus y, so it will give us the return which is x plus y. So this is our method number 1. Now here I just write public integer add, then int x, int y, and the integer z. This is our method number 2, and here I just need return, and the return is integer x plus y. Now here I just go to the method number 3. Sorry, it's not an integer x plus y here, so x plus y plus z here. Now here we have the method number 3, which is the integer add, and then int, and here I just define double, so double x and then integer y. So our method number 3 is return, and the return here is integer, and which is x plus y. Okay, now we just go to the method number 4, public integer add, and then integer x, and here I just take the double as a y, and now here I just write return x plus and then integer which is y. Okay, now I just make a class which is the name of test.java, and here I just define the main method which is public static void main, and then string which is the arguments here, and then here I just write system dot out dot print line, and the print line is here I just write the name of the class, and the name of the class here is, so not here I just create static polymorphism, and then here I just write the class name which is static and new polymorphism. Okay, and now here I just write, so I just give it the static one. Okay, now here I just write static one dot add, and here I just give it the value to the parameter which is 2 and 3. So I just call the method number 1 here. Now I just copy this for the method number 2, 3, and 4. So in print, and here I just give it the value which is 5, and then here I just write 3.4 and then 2.6 here. So I just call 4 methods here. So this is for our method number 3, because I just write it the double x here, so this is for our method number 3. Okay, so here I just run this code, and okay, so you can see we have the addition of our first method, this one, 3 plus 2 is equal to 5, and then 2 plus 3 plus 5 which is equal to 10, and then 2 plus 3.4, because it's a float value, so it just take the 5 here, and then 2.6 and then 3, and let's take 5 as a value. So now we just see the example of dynamic polymorphism. Suppose a subclass overrides a particular method of a superclass. Let's say in this program we create an object of a subclass and assign it to the superclass reference. Now if we call the overridden method to the superclass reference, then the subclass version of a method will be called. So now here I just create a package which is poly here, and then in this I just define the class which is dynamic.java. So we have the dynamic polymorphism, or I just remove this, delete this class, and here I just create the example for vehicle.java. We have the package name which is poly and the class name which is vehicle. Here I just write public void and move. Then here I just write system.out.println, and then vehicles can move. Okay, now here I just create a new class which is car.java. Here I just extend this vehicle here, and it's a vehicle, and now here I just take it the output which is system.out.println, and it's system.out.print, and the print is the line here, and then we have, I just write car can move and accelerate too. Okay, and here it's a string, and then here I just create a class which is a name of test.java. So I just copy this, and here I just write system.out.print, and the print is a line here, and yes. Okay, it will give us the error because I just not declare a function. I just forget to declare the function here, or a method. So now it's work good, and now just turn to the test class, and this is a colon here. And now in the test class I just define the main method. So public is static and the void main, and then string arguments. And now here I just write the class name, means the super class name, which is vehicle, and here vh which is equal to new car. And now here I just write vh dot move. So this will print the car can move and accelerate too. And then vh object dot new vehicle. So I just call this object, and then vh dot move method. So it will print the vehicle can move. Okay, and here I just use is equal to sign because I just make a little mistake with the point. So I just run this code, and now you can see car can move and accelerate too. So I just call this object, which is method which is move, and then it will print vehicle can move. So here the simple examples for dynamic and the static polymorphism in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we are going to be discussed about method overloading in Java. Method overloading is a feature that allows a class to have more than one method having the same name. If their arguments list are different, there is similar to the constructor overloading in Java. That allows a class to have more than one constructor having different argument lists. Here is the question why we do method overloading in Java. In such cases, we can create the methods with the same name and the signature as in the parent class. This way, the new method masks the parent method and would get invoked by default. Overloading in Java is the ability to create multiple methods of the same name, but with the different parameters. Overloading occurs two or more methods in one class have the same method name, but different in parameters. Remember that. Here we have three steps to create the method overloading in Java. Number one, number of parameters. Here you can see I just write add and integer. These are the numbers of parameters. We have the two numbers of parameters here. This is a valid case of overloading. Or you can write add int and integer of 3 times. Okay, so this is the valid case of the overloading. Our second process or method to overload in Java, so which is data type of the parameters. So you can see add integer and integer, then add integer and float. Okay, so these are the data types of the parameters. Number third, sequence of data types of the parameters. Like here you can see add integer and float, then add float and the integer. So what are the invalid case of the method overloading in Java? When I say argument list, I am not talking about the return types of the method. For example, if two methods have the same name, same parameters, and have the different return types, then this is not the valid method overloading. This will throw exception error. Like here you can see integer add and it have the parameters like the data types which is also int, and then float add and it have the integer data types. So this is the invalid case because they have the different return types here. So for our these three methods, when I say argument list, it means that the parameters that are a method that has a method. For example, the argument list of the method add integer a and the integer b, which have the two parameters, is a different from the argument list of the method add, like add integer. Here I just write integer a and the integer b, and then here is example integer a, integer b, and integer c. These are having the three parameters here. So now we just go to the method overloading example. So I told you in the last lecture, the method overloading is an example of the static polymorphism. So here's the some point which are static polymorphism is also known as compile time binding or early binding. I just told you in my last lecture. And the static binding happens at the compile time method. Overloading is an example of static binding where the binding of the method called to the definitions happen at the compile time. So now we just go to the example of this method overloading. As I discussed in the beginning, method overloading is done by declaring the same method with the different parameters. The parameters must be different in their numbers, sequence, or types of parameters or arguments. Now let's see the example of this method overloading. And here I just create a class which is method.java. So in the method overloading class, I just create a method which is display, and then here I write system.out.println, and the println here is I just write, and this is the println, and then here I just write method overloading. Okay, and then we just go to the second function. So void is a display here. So void means it will not return nothing, and the parameters of this is x. Then system.out.println, and the println here is integer value. Okay, then we just go to the third method which is for display, and it will give us the float value which is x, and the float value here is system.out.println, and the println here is character. So float values, and here I just write float value. Okay, now we just define one another method which is the name of display, and the parameters here are character x, and then I just write system.out.println, and the println here is character value. Okay, now after that I just go to the void function and pass the two parameters here which are the return types of integers. So display integer x and the integer y here. Okay, and here I just write system.out.println, and the println here is integer and the integer, and after this I just concatenate x and concatenate y. Okay, now here, sorry, it's plus y. Now I just write void and display, which is the two return types, which is data types, which is float and integer, and here I just write system.out.println, and the println here is float and then the integers, so plus x and then plus y. So now here I just write another function which is, so this is integer and float. So void display and the display here is I just write float for the first data type, and the second one is the integer, and then system.out.println, and the println here is float and the integer, and then plus x and the empty string for the comma, and plus concatenate y. Now I just create the main class to call the object of this, to create or call the object of this function. So this is the main class here, and then I just create the main method, which is static void main, and then string arguments, and the string arguments here is I just write the class name, which is method, and I just create the object with the method, which is equal to new method. Okay, and now I just call the method here. So first one is display, then object dot display integer, and the integer value here is I just write 525, and then object dot display, so object dot display, which is for float, and the float x value here is I just write float, and the float value here is 6.23. Then object dot display, and display for the characters, so the character here is Z. Okay, and now I just create another object dot display for our two integer values, so yes, integer x and integer y. So here the integer value is 45 and the value of y is 63, and then object dot display for the integer and the float value. So our integer value here is 963, and the float value here is I just write float, and then here I just write 202.35369. okay, or here I just write 69. Now I just write object dot display, and display for the float and the integer. So our float value here is 523.89, and then the integer value here is 20. Now I just check the output for this code. So we have the first display method, which is the float value and the character values method overloading. You can see the display method, and then here we have the integer value, then we have the float value, and then we have the character values here, and it will give the two integer return types, which is 45 and 63, and then integer and float values here, and then float and the integer values. So this is a method overloading example in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we are going to be discussed about method overriding in Java. If subclass like child class has the same method as declared in the parent class, it is known as a method overloading in Java. In other words, if subclass provide the specific implementation of the method that has been provided by one of its parent class, it's known as method overriding. So what is meant by method overloading in Java? The benefit of overloading is ability to define a behaviors that is specific to the subclass type, which mean a subclass can implement a parent class method based on its requirement. In object-oriented terms, overriding means to override the functionality of an existing method. Why we use overriding in Java? The ability of a subclass to override a methods allow a class to inherit from a superclass. Those behavior is close enough, and then to modify behavior as needed. Overriding is a feature that is available when using the inheritance. Here, one another definitions of overriding in Java. So, declaring method in a subclass which is already present in the parent class. It's known as method overriding. I just told you overriding is done so that is a child class can give its own implementation to the method, which is already provided by the parent class. In this case, the method in the parent class is called overridden method, and the method in the child class is called overriding method. In this lecture, we will see what is the method overriding in Java and why we use it. So here, let's take a simple example to understand this. So here, I just create a class which is human.java. Okay, we have the methods to the human which are eat. So here we will take two classes. In this method overriding, we are taking two classes. First one is a human, and then I just take one another class which is boy, and it's boy.java. Okay, so a child class boy and a parent class human. The boy class extend the human class. Both classes have the common method which are eat. The boy class is giving its own implementation to the eat class, eat method, or in other words, it is overriding the eat method. The purpose of method overriding is clear here. The child class want to give its own implementation to that's when it calls the method. It's print the boy is eating instead of human is eating. Here we just go to the example and see the method overriding. So here it's a public void and eat. So the human is eating. So this is the overridden method. And then you can see, and I just remove this and see system.out.println here. And the print line here, which is the name of human, and human is eating here. Now we just go to the boy class. So class boy extends human. Okay, remember that. And it's human. Okay, and it's a capital human. So yes. So here I just write public void and eat method. So now here, which is the eat method, which is overriding method here. So I am just using the overriding method here. But here I just use the overridden method. Okay. So I just go to the boy class and here I just write system.out.println, and the print line here is boy is eating. Okay, and then the main method, which is public static void main, and then string arguments. Okay, here, and then I just create the object to the boy class and boy object, which is equal to new boy. Okay, and now here I will call the child class version of eat. So here I just write object and eat. So I just call the eat. So you can see here boy is eating. So you can see here the boy extend the human class, which have the same method, which are the void eat. You can see the boy have the same method of eat, and the human have the same method of eat. The boy class giving its own implementation to the eat class, sorry, the eat method, or in other words we can say it overriding the eaten method here. Now we see what are the advantages of the method overriding. The main advantages of the method overriding is that the class can give its own specific implementation to the inherited method without even modify the parent code's class code. This will helpful when a class has several child classes. So if a child classes need to use the parent class method, it can use it, and the other classes that want to give the different implementation can use overriding features to make changes without touching the parent class code. Here we have one another example of this overriding, and now I just see just make uh, another example. So here I just said method overriding one, and now here I just create a class which is method dot java, and here first of all I just create a method which is the name of display, and then here I just write system.out.println, and the print line here is class method. Okay, now I just go to the another class and the quotation here, and I just go to the another class which is a subclass of the method class. Now here I just extend method. Okay, and then here I just write the same method name which is display, and then here I just write, I just use the super keyword. So I just tell you about the super keyword in my upcoming lectures, so just make a concept here. So the super and then display, and then I just write system dot out dot println, and the print line here is class and the sub class. Okay, now I just go to the main class where I just create the object to these classes. So here I just declare the main method which is public static void main, and then string and the arguments, and here sub class object which is equal to new sub class, then object dot, and then object dot display. Okay, now we just check the output. So here we have the two methods are calling which have the same method as display. So first one is a class method. We have the same method for this class which is the method, and then the subclass. You can see I just call the super method here. So use the super keyword and then call the display method and get the value from this method which is a class, and the subclass. So these are the concept of method overriding in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we are going to be learn about the super keyword in Java. Super keyword in Java is a reference variable that is used to refer the parent class object. Super is an implicit keyword created by Java Virtual Machine and supply each and every Java program for performing importance role in three places, like at variable level, at method level, and at constructor level. The question is why we need the super keyword. Whenever the derived class is inherits the base class features, there is a probability that base class features are similar to the derived class features. And Java Virtual Machine gets an ambiguity in order to differentiate between base class features and derived class features must be preceded by the super keyword. The syntax of the super keyword I just used in my last example, which is the main.java. Yes, here subclass.java. You can see here you can write the super keyword and then the super display name or any the function name. When add the super at the variable time, so whenever the derived class inherit base class members, there is a probability that base class data members are similar to the derived class data member, and the JVM gets ambiguity. In order to differentiate between the data members of the base class and the derived class in the correct of the derived class, sorry, the context of the derived class, the base class data members must be preceded by the super keyword. Now we can see the actual syntax of the super keyword. So super, and then you can write the base class, and then the data member and the data member of the name, like super the base class name, then data member integer float, and then the name of this. If we are not writing the super keyword before the base class data member name, then it will be referred as a current class data member name, and base class data members are hidden in the context of the derived class. Here we are going to be create a program without a super keyword, and here is example of Java employee, and then the class employee, and here I just write float salary, which is equal to 1 lakh. Now I just create one class with the name of HR department, so HR and the Java. So here float. Okay, now in the HR class I just extend employee. Okay, and then here I just take the salary as a float, and which is equal to 2 lakhs. Now here I just use a function or a method which is display, and then here I just write system dot out dot println, and here's a println is salary, which is a concatenation of salary. So it will print the class which is salary. Okay, and now I just go to the super variable, and here I just create a class which is super variable dot java. Here I just define the main method, and which is strings and the arguments, and here the hr, which is the object is equal to new hr, and here I just create the object which is display. So I just display only the object of this hr. Here I just run this code, and so it will give us the salary which is 2 lakhs. So in this example, in employee and the hr class, like this one, employee and the hr class is common properties of the both class. The instance of cur- current of or a derived class is referred by instance by default, but here we want to refer the base instance variable. That is why we use super keyword to distinguish between parent or base class instance variable and current or a derived class instance variable. So here is a program where we use super as a keyword in method label. So here I just write the source, and this is a package, and then here I just write super keyword 1. Okay, and now I just create a class. The class is the person here, and in the person class I just write void message. So this is a function of my person class, and then print line, and this is person class. Now I just create another class which is a subclass. So here I just write the name which is student. So again I just write the method, and then system dot out dot print line, and the print line here is this is student class. Now note that display method is only the student class method. So here I just write void display, and then I just invoke the method which is display here. So message, and then I just use super dot message keyword. Okay, sorry, the super keyword and the message here. So this will invoke the parent class method. Now I just go to the another class, and then I just write test.java. So here the public static void, and the main method, and then string arguments, and then student s, which is equal to new student, and then I just call the display of the student, so s dot display. Okay, and here super and the message. Okay, now here I just extend the person here. Okay, and I just run this code. So there is an error. So main method is not found in the class of super keyword dot person as a main as a static. Yes, here in the test class. So display, and so I just run it again, and this is the student class and this is a person class. You can see it will retrieve the data from both the classes with the help of super keyword which have the same method name. Here I just point out some important rules for the super class. So whenever we are using either super or a super means like this one, super keyword, or the super keyword with any something. So in the derived class constructor, the super always must be at the first executable statement in the body of the derived class constructor. Otherwise, we will get the compile time error. So the rule number one is whenever the derived class constructor want to call the default constructor of the base class in the context of the derived class constructor, we write super, which is optional to write because every base class constructor contains the single form of the default constructor. And whenever the derived class constructor want to call the parameters constructor, so this is a parameter constructor to constructor of the base class in the context of the derived class constructor, we must write the super like this super when we use the constructor as a parameters, so which is mandatory to write because a base class may contain multiple forms of the parameters constructor. So these are some examples and the super keyword in Java. Thanks for watching this lecture. See you in. Welcome to this lecture, and in this lecture we are going to be discussed about this keyword in Java. This is a keyword in Java. It can be used inside the method or a constructor of a class. This work as a reference to the current object those methods are or constructor is being invoked. This keyword can be used to refer to any numbers of current object from within an instance method or a constructor. On the other hand, this is a reference variable that refers to the current object, and simply it is a keyword in the Java language represent the current class object only. The usage of this keyword is it can be used to refer the current class instance variable. This can be used to invoke the current class constructor. It can be used to invoke the current class method implicitly. It can be passed as an argument in the method call. It can be passed as an argument in the constructor call. And it can also be used to return the current class instance. The question here is why we use this keyword in Java. The main purpose of using this keyword is to differentiate the formal parameters and data members of a class. Whenever the formal parameters and data members of the class are similar than Java virtual machine, it will get ambiguity. No clarity between the formal parameters and the members of the class. The differentiate between formal parameters and data members of the class, the data member of the class must be preceded by this keyword. So this keyword can be used in two ways. One is, and here I just give the example, one is this dot. So this is the name of this dot, and another one is this keyword. So this is called this of. So like this one, this. So let's take a look on this dot. So this dot, which can be used to differentiate variable of the class and formal parameters of the method or the constructor. This keyword are used for two purposes. They are it will always points the current class object, and the another one is whenever the formal parameters and data members of the class are similar and the Java virtual machine gets an ambiguity, means no clarity between the formal parameters and the data members of the class. To differentiate between the formal parameters and the data member of the class, the data member of the class must be preceded by this. So here is a syntax of this keyword. So this and the data, and then member of the current class. Okay. Note that if any variable is preceded by this, Java virtual machine treated that variable as a class variable. Now we just see the example of this keyword. So before starting this example, we just need to know the this keyword with the field instance variable. This keyword can be very useful in handling of the variable hiding. We cannot create two instances or a local variable with the same name. However, it is legal to create one instance variable and one local variable or a method parameters with the same name. So here we just see the example of the this keyword with the variable hiding. Here we have the class name, which is this one. Then I just create a data type, which is the integer, and integer is variable, and variable which is equal to 5. Then I just use the main method, which is public static void main, and the string arguments. And here I just create this one and the object which is equal to new this one. So I just create object to my this class, and here I just write obj dot method, and which is 20, and then obj dot method, which is nothing, and I just close this code here. Now here I just define these methods where void and method. So method here is the data type of int variable, and I just copy and paste this name here, and then I just write variable which is equal to 10. Now I just write system dot out dot print line, and the print line here is value of variable, and then I just concatenate the variable here. Now I just write void and method. So integer variable which is equal to 40, and then system dot out dot print line, and the print line here is value of variable, and then I just concatenate variable here. Now I just check the output for this code. So I think I have an error in this package. I just create one another new package, which is this, and here I just create a class which is the name of this one, and I just copy this code and paste it here. I just remove this class and one curly brackets. And now I just run this code. So you can see value of the variable is 10 and the value of variable is 20, because this method which have the parameters is the value of 10, and then I just call one another method with the name of the method which is the value of variable which is 40. Now we see the example of this keyword with the constructor. This keyword can be used inside the constructor to call another overloaded constructor in the same class. This is called explicit constructor annotation. This occurs if a class has two overloaded constructors, one without arguments and one with arguments. Then this keyword can be used to call constructor with an arguments from the constructor without arguments. This is required as a constructor cannot be called explicitly. Here I just create a new class, and the class name here I just write this and one, and then here I just use this keyword and then write this one and close this code here, and then I just write system dot out dot print line and this one, and the print line here is inside constructor without parameters. Okay, and then I just create the method for this one. So this is the name of the method, and now here I just write this one and then string str, and show me the error because I just not create the variable method which is this one. So constructor call must be first statement in the constructor. I just remove this word with my this function. So here the str, so this is the method of the string, and then I just write system dot out dot print line, and the print line here is inside constructor with string parameters, as I just write quotation and then plus string. So I just concatenate my this string here. So as you can see, this can be used to invoke an overloaded constructor in the same class here. You can see here this can be used to invoke an overloaded constructor in the same class. Now we just go to the main method here. So public static void main and then string arguments, and then this one object which is equal to new this one. Okay, and then I just close this code. Now I just check the output for this code. So you can see the inside constructor with the string parameter at this one and inside the constructor without the parameters. You can see here like this can be used to invoke an overloaded constructor in the same class. So here note that this keyword can only be the first statement in the constructor. Our constructor can have either this or super keyword, but not the both. Now here I just use one another example with the this keyword with method. So I just give it the name of method here. So class name which is this method, and now public static void main. It's a main method here, and then arguments, and then this method object which is equal to new this method, and then object dot method 2. Okay, so now here I just write method void and method 1 and method 1, and then system dot out dot println, and println is inside method 1, and then void method 2, and then system dot out dot println, and the println here is inside method 2, and here I just write this dot method 1. So I just call the method number 1 same as a calling of method number 1. So now I just check the output for this. So you can see inside the method number 2, because I just use the object of method number 2 here, and then inside the method number 1. So I just create the method 2. This one is here in the method number 2. So this is example of this keyword with the method. So these all the examples of these keywords in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be learn about the encapsulation in Java. Encapsulation simply means binding object states, field, and behavior methods together. If you are creating the class, you are doing encapsulation. In this lecture, we will see how to encapsulate in Java program. The question here is, what is encapsulation? The whole idea behind encapsulation is to hide the implementation's details from the user. If a data member is private, it means it can only be accessed within the same class. No outside class can access private data member variable of other class. However, if we set up the public gather and setter method to update, for example, here I just write void and set ssn and then int ssn and read like int get ssn here. The private data field, then the outside class can access these private data field via public methods. This way, data can only be accessed by public methods, thus making the private field and their implementations hidden for outside classes. This is why encapsulation is known as data hiding. Let's see the example of the encapsulations to understand the better concept of the encapsulation. So here I just create a class with the name of encapsulation. You can see here I just write the private int ssn. So this data member is private here. So now I just write private string and employee name. Now this is also private, this detail hidden from the user, and int emp employee age. Okay, now we just gather the setter method here, public string and get emp ssn. So this is the method and it will return us ssn. Now here I just write public string and then get emp name. Okay, so this is a method here for the employee name and it will return emp name. Okay, and this is return ssn here. So it's not a string, it's an integer here, that's why it's giving an error. Now public static, sorry, it's not, public integer and get emp age. So this is a method for age and return employee age here. Now here I just write public void and set emp age, which is integer, so which is the integer of new value. So these are the parameters to my set emp age method. And now here I just write emp age, which is equal to new value. And then here I just write public void set emp name and then string new value, then emp name here, which is equal to new value. Okay, and then it's public void set emp ssn and then integer, which is the new value here. So integer, which is the new value here. Okay, and now I just write ssn, which is equal to new value. Now here I just create a new class with the name of incaps test.java, and here I just write public static void main. So this is the main method here, and then here I just write string arguments and then encapsulations mean I just create an object to this class. So encapsulation object, which is equal to new encapsulation. Now object dot set, and it's an static here, so object dot set employee name here, and then values here are Fayaz, and then object dot set age, and the age is 25. Then object dot set ssn, and which is the ssn number is 12223. Now here I just write the print statement, so print line and then employee name and then I just concatenate the object here, which is obj dot employee name, then system dot out dot print line, and the print line here is employee ssn, and then I just concatenate object dot set ssn number, and there is no value. So now here I just write system dot out dot print line, and the print line here is employee age, and then just concatenate object dot get employee name. Sorry, not get employee name, it's employee age. And here I just write object dot get employee ssn number. So here I just make the instance variable private, you can see, so that they cannot be accessed directly from outside the class. I just access with the help of object, and then I just print the statement and concatenate these um, variables. You can only set and get the values from these variables through the methods of the class. You can see I just create the many methods of the class for get employee ssn, then get employee name, and get employee age. So here you can see I just take the data types, which is a value of new value. So, and then you have the getter and the setter method in the class to set and the get the value from the field. You can see I just set the gather and the setter method here. You can see public static uh, public int get employee ssn. So these are the getters and the setters methods here. So what is a gather and the setter method? Gather and the setter methods are used in encapsulations the field of class by making them accessible only through this public method and keep the value themselves private. This is considered as a good object-oriented principle. It's not correct rather, and the setter methods are used to get and set the values of any of the integer or any of the value, which is the way to achieve the encapsulation. So now we just see the advantages of the encapsulation in Java. It is important, it means encapsulations improves the maintainability and flexibility and reusability. For example, in this code, the implementations code of the void get employee name means here where yes employee get employee name and string employee name, and here the string employee name. So it can be changed at any point of the time. Since the implementation is purely hidden for outside the class, they would still be accessing the private field employee name using the same method like set employee name string name, and get employee name. Hence, the code can be maintained at any point of the time without breaking the classes that use the code. This improves the reusability of the underlying class. Another advantage is that the fields can be made read only. If we do not define the setter method in the class, or write only if we do not define the gather method in the class. For example, if we have field or a variable that we do not want to change, so we simply define the variable as a private, and instead of the set and get both, we just need to define the get method for the variables.
Since the set method is not present, there is no way an outside the class can modify the value of that field. The third advantages of encapsulation is user would not be knowing what is going on behind the scenes. They would only be working with the update a field called method and the read a field called method. But they these set and get methods are doing is purely hidden from the user. So the main um, advantages of the encapsulation is data hiding from the user. So encapsulation is also known as the data hiding. So here I just tell you what is different between the abstractions and the encapsulation, because we also do the data hiding in this abstraction. So abstractions are in Java, abstractions solve the problem in the design level, and in encapsulation the encapsulation solve the problem of the implementations level. Means abstraction solve the problems on the design level, but the the abstraction solve the problem in the design level, and the encapsulation solve the problem at implementation level. Abstraction is used for hiding the unwanted data and gives the relevant data only. But the encapsulations mean hiding the code and the data into a single unit of the protect and data from outside world. Abstractions let you focus on what the object does instead of how it does it. But encapsulations mean hiding the internal details or machines of how an object does something. And the abstraction is an outer layout used in the term of design. For example, outer look of a mobile phone or any of the website, like it has a keypad buttons to dial a numbers or a display screen. But the encapsulation is an inner layout used in term of implementations. For example, inner implementations details of a mobile phone, how display screen and the keyboard are connect with each other using circuits. So here is a real world example to differentiate between the abstractions and the encapsulations. Like you have a mobile phone, okay, and you can dial a number using keypad buttons. Even you don't know how these working internally. This is achieved in Java abstraction. But how the mobile phone internally works and how keypads buttons are connected with internal circuits, this is achieved using encapsulation. So this is the example of the encapsulations and some methods and some rules and some advantages of the encapsulation in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. And in this lecture, we are going to be discussed about the packages in Java. Packages are used in Java in order to prevent the naming conflicts to control the access, to make searching location and usage of classes interface enumerations and annotations easier. A package can be defined as a grouping of related types, which are classes, interface, and enumerations and annotations, providing access protections and namespace management. The purpose of the package is the concept is to provide the common classes and interfaces of any program separately. In other words, we want to develop any class or interface which is common for most of the Java programs. Then such common classes and interfaces must be placed in a package. Like here you can see I just create a package name. So this is our package, which is an abstraction. So Here I just create a class which is circle, or I just write here we have the two same classes with the name A and A. So that's why we just use the package here. Here we have a diagram of the package. So you can see a simple example like our package name is a Java. Then we have the sub packages of the Java, like the library for the Skinner, Lang, and the GUI, like AWT. You can see we have the map class with util, then language class with the system class and the string class, and then the GUI, which is the button classes. So that's why I just create the package of the Java, then sub packages, and then different categories of GUI, scanner class, and Lang class. The package in Java are the way to organize the files. When a project has many modules, some like we organized our file in computer. For example, we store all the movies in one folder and song in another folders. Here also we store same name of the file in the particular package of the particular package. For example, in AWT package have all classes and interface for design GUI components. You can see we have util and lang, then SQL AWT package here in Java, and then computer we have the movies, songs, ebooks, software, which are the folders. What are the advantages of the package? Package is used to create the classes in an interface so that they can be used easily and maintained. Application development time is less. You can see application development time is less because reuse of code. We just use many time of codes here in these packages. You can see now application execute time is less. If I just create a many classes in one package, you can see so we have the execution time is much higher than these two classes. Redundancy or repetition of code is minimized here. Application's performance is enhanced, improve. Package provide access protections, and the package removes naming collision. There are two types of packages which are packages are predefined or built-in package and user-defined package. So what are the predefined or built-in packages? These packages are which are already designed by Sun microsystem and apply as a part of Java API. Every predefined package is collection of predefined class interface and sub packages. What are the user defined packages? The user defined packages are if any package is designed by the user is known as user design package. User defined design package are those which are developed by Java programmers and apply as a part of their project to deal with the common requirements. So these all are the user defined package, and this is a default package which is a built-in. So here's the some rule to create the user defined packages. Package statement should be the first statement of any package program. Choose an appropriate class name or an interface name, and those modifiers must be public. Any package program can contains only one public class or only one public interface, but it can contain any numbers of normal classes. Package program should not contain many classes. That means it should not contain any main method. Modifier of a constructor of the class which is present in the package must be public. Means this is not applicable in the case of interface because interface have no constructors. The modifier of the method of a class or interface which is present in package must be public. Means this rule is optional in case of interface because interface method by default public. Every package program should be saved either the with public class name or a public interface name. Like here we have sum.java program class and save the package program with public class name. Then package my package name, which is the first statement of the Java program, is package. Then public class sum and class modifier must be public here. Then public sum and constructor modifier must be public in these case too. Then system.out.println, which is some class constructor. And then when we use the void method, so modifier must be public. And then system.out.println. The compile package programs. So for compilation of the package program, first we solve the program with public class name.java, and then it will compile this syntax like Java C minus D class name and then Java, or a syntax of the path like Java C and then path class name dot Java. So in this syntax, minus D is a specific tool which is to tell the Java compiler create a separate folder for the given package in the given path. When we give a specific path, then it create a new folder at that location, and when we use dot, then it create a folder that current work directory. Note that any package program can be compiled but cannot be executed or run. These programs can be executed through user-defined programs, which are importing the packages program. Here, I just create example of this package, and then in the source, I just create a package which is the name of my package. Okay, here I just create a class which is the name of a.java. Here you can see my package and my package. Then the public class a, and here I just create a method which is public void and show, and then system.out.println, and the print line here is some method, and then I just create a new class with the name of hello, and then I just write public and class hello. So in the public class hello, I just write public static void main and then string arguments, and here I just write a which is equal to a and object of a which is equal to new and a, then a dot show, and at the last system dot out dot print line, and here I just write show, and show is class a. So here remember that here I just import a library which is my package dot a. You can see here, and then I just run this code. So some method and then show and the class show. So in this example, the first we create the package program which is saved with a.java and compiled by java c minus d dot a dot java, and then again we import the class a in the hello using the import my package.a statement. So here I just add some more information about the package. So different between the package and inheritance are inheritance concept always used to reuse the feature within the program between the class to class and interface to interface and interface to class, but not accessing the feature across the program. The package concept is to reuse the feature both within the program and across the program between class to class and interface to class. And different between the package keyword and the import keyword. So package keyword is always used to creating the undefined package and placing common classes and interface. And import is a keyword which is used for referring or using the class and interface of a specific package. So this is some information about the packages in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about the access modifier in Java. Access modifiers are those which are applied before data members and the methods of a class. They are used to where to access and where not to access the data member or methods in Java programming. These are classified into four types. First one is private, then default which have the no keyword, then protected and public. Note that default is not a keyword like public, private, protected or keyword. If we are not using private, protected and public keywords, then Java Virtual Machine is by default taking as a default access modifier. Access modifiers are always used for how to reuse the features within the package and access the package between class to class, interface to interface and interface to class. Access modifier provide features accessing and controlling mechanism amongst the class and the interface. Here you can see the class B and the class A and class C. We have the two packages where in class A we have the private, public, protected and default. In private, the accessible of class A is no one, means we cannot access class B and class C. But in public we have access to the both class which are class C and class B. Protected have the only access of one class which is class B, but it cannot have the access of class C. In default, the same like the protected, it have the access of class B, but it have no access of class C. Note that protected member of the class are accessible within the same class and another class of the same package and also accessible in inherited class of another package. Here we have some rules for access modifier. So first one is our private. So we can access within the same class, but within other class of same packages we not access the private modifier. Within derived class of another package we cannot access the private modifier, and within the external of other package we cannot access the private modifier. In default we can access the same class, we can access it in within the other class of the same package, but we cannot access the derived class of the other package and external class of the other package. Now the same case like protected, within the class we can access it, with other class of the same package we can access protected modifier, and within the derived class of other package we can access this private protected modifier, and within the external class of the other package we cannot access protected modifier. And the public modifier is a universal modifier. We can access it in any level or any stage or any of the package or the class in our Java. Private members of a class is not accessible anywhere in the program. These are only accessible within the class. Private are also called class level modifier. Here I have an example of private modifier which is the class private one, and then I just use a modifier which is int private int a which is equal to 20, and then private void which is show, then system dot out dot print line, and the print line here is hello private modifier, and this is private. Okay, and now we just go to the another class which is private 2 dot Java. Here I just define the main method, so which is public static void main and string arguments. And then here I just write private one and the object to my private one class and new private one. Okay, and then system dot out dot println, and the println here is object dot and the object to my a private modifier. Now I just check this private and this is a okay. So at the compiler time error, you cannot access private data and then object dot show. So here the compile time error, you cannot access the private method here, means you cannot access the private data and you cannot access the private method. So that's why they are giving the error here. Now we just see the public member of any class are accessible anywhere in the program, in the same class and outside of the class, within the same package and outside of the package. Public are also called universal access modifier. Now we just change these two classes with the public. So here we have int20 and then the method is show, and here I just write it's a public modifier, and I just go to the public class 2, sorry, the private class 2, and here the main method and same like private 1 and object and then string. So I just simply change this private with public and public. You can see the error is automatically cleared here when I just run this code. So the output for this code is 20 and hello public modifier. Now we just see the example of the protected modifiers. Now protected member of the class are accessible within the same class and another class of the same package, and also accessible in inherited class of another package. Protected are also called derived level access modifier. Now here I just remove this example and then I just create a class which is pack1.java and then create another class with pack2. So now here in this class I just write public class A. So it's a public class package and our package name is access modifier. So here I just write protected void show. So this is a method here, and then I just write system dot out dot println, and the println here is hello I am protected. So now just go to the I just remove this class, and in the access modifier I just create a package with access modifier 1. So here I just create a class which is pack2 and then I just import which is access modifier, and I just not to import here, I just transfer this file in the same package, and here I just write import access modifier and dot static and dot, here I just write pack1. Okay, here I just use a keyword which is extend and extends package number 1. Now here I just write public static void main strings string and the argument. So package number 2 and create an object to it which is equal to new pack2 and then object dot show. Now I just run this code so you can see hello I am protected. So in this example we have created the two package which is pack1 and pack2. In pack1 class pack1, so here I just create a package which is access modifier and the two classes which is pack1 and pack2. So in class pack1 is a public, so we can access this class outside the package, but method shows is declared as a protected, so it is only accessible outside of the package. Number one, sorry, access modifier in the package access modifier only through the inheritance. So now we just go to the default access modifier. So default member of a class are accessible only within the same class and another class of the same package. The default are also called package level access modifier. So here I just create a package which is default access and then create a class with the name of class a.java. Here I just write void show, it's a method here, and then system.out.println, and the println here is hello default. Okay, now we just go to the another class which is b. So we have the class b, and here in the default package, so and I just write import, and import is default access, so it's default access and dot a. Okay, and then public static void main and strings arguments, and here I just create an object, so a object which is equal to new and a, and then object dot show. Okay, so here a compile time error is not occurring, so you can see hello it's a default. So private access modifier is also known as native access modifier. Default access modifier is also known as the package access modifier, and the protected access modifier is also known as an inherited access modifier. And I just told you public access modifier is also known as a universal access modifier in Java. So thanks for watching this lecture. See you in next.
Welcome to this lecture, and in this lecture we are going to be discussed about the multi-threading concept in Java. Before we asking about the multi-threading, let's discuss the thread. A thread is a lightweight, smallest part of a process that can run concurrently with the other threads of the same process. Threads are independent because they all have the separate path.
of execution. That's the reason of an exception occur in one thread. It doesn't affect the execution of other threads. All threads of a process share the common memory. The process of executing multiple threads simultaneously is known as multi-threading. Here we have some points to summarize this discussion, which are: the main purpose of multi-threading is to provide the simultaneous execution of two or more parts of a program to maximize utilize the CPU time. A multi-threaded program contains two or more parts that can run concurrently. Each part of a program is called thread. Threads are lightweight subprocesses. They share the common memory spaces in multi-threaded environment. Programs that are benefited from multi-threading utilize the maximum CPU time so that the IDE time can be kept in the minimum. A thread can be in one or the more following states, which are new, runnable, blocked, waiting, time waiting, and terminated. So what is the new here? A new thread that has no yet started in this state. It's called new thread. Runnable thread is a thread that executing in the Java virtual machine is in this state. And the block thread is that is blocked waiting for a monitoring log is in this state. The waiting thread is a thread that is waiting identify for another thread to perform a particular action in this state. And the time waiting thread is a thread that is waiting for another thread to perform an action for up to a specified waiting time in this state. And the terminated thread is a thread that has exited in this state. A thread can only one state at the given point in this time. Here we take a look on thread lifecycle in Java. The start method creates the system resource necessary to run the thread, schedules the threads to run, and call the threads run method. Here you can see a new runnable and then non-runnable and the block thread and runnable and the terminated. So a threads become non-runnable when one of these events occur, like if sleep method is invoked, the threads call waiting method, and the thread is blocking in input and output. So a thread dies naturally when the run method is exit. So here you can see a new thread then runnable if the thread becomes non-runnable. So if the reason of that is the thread has a sleeping method, the threads call the waiting method, and this thread is blocking on input and output. So you can see when the sleeping is done, so it's just go to the runnable and then running, and then at the last terminated like run method exists. So if the running is not working here, so it's just go to the sleep block on input and output waiting for the log and suspend the wait, and then it's go in non-relevant condition, and then it is resume, and then it's start work here. So now we just see what is thread scheduling. Execution of multiple thread on a single CPU in some order is called scheduling. In the journal, the runnable thread with the highest priority is active running. Java is a priority primitive language. If a high priority thread wakes up and the low priority thread is running, then the high priority thread gets to run immediately, allows on demand processing and efficient use of CPU. Let's suppose these are the six threads here, and the runnable have the high priority than others. So the it will be execute fast instead of these all. So what are the types of scheduling in the threads? First one is the waiting and notifying, then wait, notify all, running and yielding, and then sleeping and wake up. So waiting and notifying. Waiting is a wait and modify. Modifying is a modify and modify all. Provides means of communication between the threads that synchronize on the same object. Wait when wait method is invoked on the object, the thread executing that code's given up its lock on the object immediately and move the thread to the wait state. Notify means this wake up threads that called wait on the same object and move the threads to its ready state. Now notify all is this wake up all the threads that call wait on the same object, and the running and yielding is yield is used to give the other threads of the same priority a chance to execute. For example, the causes current running threads to move to running state. And now you just see sleeping and waking up scheduling of the thread. So n sleeping is used to pause a thread for a specified priority of the time, move the current running thread to sleep state for a specified moment of a time before moving it to runnable state. Thread.sleep means no of millisecond. So threads always work on the priority base. Now we just see the what is multitasking versus multi-threading and multiprocessing versus parallel processing. So if you are new to the Java, you may get confused amongst these terms and they are used quite frequently when we discuss multi-threading. So let's talk about multitasking. So what is multitasking? So ability to execute more than one task at the same time is known as multitasking. And the multi-threading is we already discussed about it. It is a process of executing multiple threads simultaneously. Multi-threading is also known as multi-based tasking. Multiprocessing, it is same as multitasking. However, in multiprocessing, more than one CPU are involved. On the other hand, one CPU is involved in multitasking. Now we just see the parallel processing. It's referred to utilization of multiple CPU in single computer time. How to create the thread in Java. The two ways to create the thread in Java. One is extending thread class and another one is by implementing runnable interface. Before we begin with the program's code of creating the thread, let's take a look on these methods of the thread classes. We have used few of these methods in our Java like getName, priority. Get priority is alive, join, run, sleep, and start. So getName is used for obtaining the thread name. Get priority is used for obtain a thread priority, and is alive is determined if a thread is still running. Join is for waiting for a thread to terminate. Run is an entry point of the thread, and the sleep is suspend a thread for a priority of the time, and the start is a thread by calling its running method. Now we just see the example of the thread creation by extending the thread class. So I just create a class with the name of multi-threading. So and here I just extend the class which is thread. Now here I just write public void and the run method, and then system.out.println, and the println here is my thread is running state. So I just define a method which is run, and then the print line which is my thread is in running state. Then here I just write the main method public static void and main and strings and the arguments. Now I just copy this class name and create the object to it, which is equal to obj and new multi-threading. And here when I just create an object, so I just use the start. So you can see start void is thread. So I just save this code and then I just execute. So my thread is in running state. Now we just go to the another example of the thread, and here I just create a class which is the name of count, and it's count here. Now I just extend this class with thread, and here I just use count as a method and then use super keyword, and here I just write my extending thread, and then system dot out dot println, and then println is my thread created, and then just concatenate this keyword, and then start. So this is a super keyword, so start with small s and start our thread here. Now I just create a method which is for run, and then use for statement and for integer which is I is equal to 0, I is less than 10, and I plus plus. So this is a for loop here, and then I write system dot out dot println, and the println here is printing the count and plus I. Now here I just use thread dot sleep and thread dot sleep. So our thread is sleep here, means it will off for a 1 second. So I just write 1000 for my this thread, and this is a column here, and not a column, and I is less than, okay, and the thread is sleep for 1 second. Now so I just write thread dot sleep sleep for 1000. Okay, now here I just define the catch exception, and then interpreter, and interrupted thread is interrupted for exception E. So here I just write the class which is interrupted exception E. So this exception is thrown when a thread is writing sleeping, or otherwise it's occupied and the thread is interrupted either before or during the activity. So a method may wish to test whatever the current thread has been interrupted, and if so, to immediately throw in this exception. So you can write this code like interrupted exception. Okay, so I just define an exception which is interrupted, and the interrupted here is exception E. Now system dot out dot println, and the println here is my thread, and thread is interrupted. Okay, and then I just go to the another line of code, and which is system dot out dot print line, and the print line here is my thread run is over here. So I just go to the another class now, and before we just go to the another statement, so I just define one try statement here. So try and the catch, and now I just go to the another class which is extending example, and here I write the main method, so public static void main, and then here I just write a string and the arguments. Now here count and object which is equal to count new count, and then try statement exception, so while cnt dot is alive. So is alive is java.lang thread is alive method test. If this thread is alive, a thread is alive if has starting and has no yet died. So this method is used for a thread is alive if it has been started and has not yet died. And then I just start system.out.println, and the println here is main thread will be alive till the child thread is live. Okay, and now here I just write the code which is thread dot sleep and sleep for 1.5 second, so it's 1500, and then I just use catch, and catch is interrupted exception which is E, and system dot out dot print line, and the print line here is main thread interrupted, and after that I just write system dot out dot print line, and the print line here is main thread is run over. Okay, now we just check the output, and now you can see here my thread is created, and then my exception thread is 5 main, and the main thread will be alive, and head it's and the child thread is live. So it will print after 1, you can see here 1 second, 2, 3, and then 1.5 second, you can see here. So its thread is executing after 1.5 second. So this is example, or this is also example of thread creation by extending thread class. Now we just see the second method to create by implementing the runnable interface of the thread. So here I just write source package thread and create the class which is multi threading, and here I just implement because I am just using thread with the interface, so I just use implements here and runnable. So now I just write public void and run, and then system dot out dot println, and the println here is my thread is in running state. Now main method main public static void main, and then string and the arguments here. Now this class name, because I am making the object here, so multi-threading obj which is equal to new and multi-threading. So I just call the thread here which is obj thread obj which is equal to new thread. So I just make the object to the thread here, and I just change the name of this object which is object number 1, and I just call my this object here in the thread. So object 1 dot start here. So now I just run this code, and here you can see my thread is in running state because I just create an object to my multi-threading class here, and then I just call this object in my thread, and the answer of this is my thread is in running state. So we see in this lecture we made thread by creating the thread class, and we just made a thread with implements like the interface. But what are the advantages of multi-threading in Java? So it does not block the user because threads are independent and you can perform multiple operations at same time. You can perform many operations together, so it saves our time. And then threads are independent, so it does not affect other threads. If exceptions occur in a single thread, so it will handle it. So this is the multi-threading concept in Java. Thanks for watching this lecture. See you in next lecture.